Hi everyone, looking forward to this next video. We're going to be going back into Serverpod like the last series, except this time we're going to be focusing on the socket-based integration you can do with Serverpod. So instead of making API requests through a standard HTTP RESTful API, we'll be talking to between the client and the server through a WebSocket for basically like live integration. This can be used for things like building a chat program or some kind of multiplayer game, various other things that sockets are useful for. What we're going to be building, though, is a little bit of a fun thing. If you're familiar with this sort of concept, maybe you've been at a friend's house and there's these little magnets on a fridge, and you can kind of move them around and make sentences and leave funny notes for your buddies. So we're gonna build something like this, and the idea is it would be either a native app or a web app built in Flutter, where it's sort of this one centralized place where you can go and change what's written on the fridge, and other people can then come and see it and change it too. So it'll be full live sort of multiplayer kind of thing. Simple enough to, I think, address the concepts that we need to do to get this working with Serverpod. So without further ado, we're just going to get right to it. So let me just get my terminal open here. And I've already installed Serverpod, but if you don't, you'd want to make sure you've installed it and then activating it. You can, nothing's different there from my last video. And we can just make sure it's running by running Serverpod. We'll see, a response came back, so we know everything is good. So we're going to create our first project here. So Serverpod create, and I'll call this Flutter Fridge. And it's going to run and kind of download stuff and do pub get things and all that kind of stuff. And there we have it. So let's go into that directory, cd flutter fridge, and I will just simply open this whole project in VS Code. So if you're not familiar with what Serverpod really is, definitely check out my last series or just read their docs. It's a cool project that lets you have kind of build your front end and back end in Dart. And I think the main difference between this and Dart Frog is it really is meant for Flutter. From front to back, you're working in Dart sort of code, and when you're creating different classes and whatnot, there's sort of like a lot of code generation that happens through this thing called your client. And essentially, it doesn't feel like you're working with an API at all because you're kind of just working with your Dart models and everything. And it gets you because of all the code generation, you automatically get IntelliSense and all the endpoints you make, and so on and so forth. Okay, so yeah, we're just gonna get into this. I'm gonna open up the server part. That's usually a logical place to start so we can start getting some data. And what we're gonna wanna do, and I will be moving through some of this stuff pretty quickly if it doesn't have to do with the socket stuff, because I did do a whole series on, how sort of the general inner workings of Serverpod works. But essentially, we're gonna go into our lib source folder of the server, and we're gonna go into protocol. And this already has an example file, so this is an example model. But we're going to make a new model, and we're going to call it magnet.yaml. And each one of these instances of a magnet will represent essentially the, which I have closed, but here it is, one of these little guys. It'll have a word associated with it and a position on the fridge, an X and a Y. And we might do a couple other fun things with it too. So to get this going, we're going to start with defining its class, and this is going to be called magnet, like this, and it is going to be database driven. And the reason we're going to even though you could build this all without without saving the database, the problem is if your server ever restarts and goes, or something happens and you lose the memory, your fridge would be wiped. This will allow us to actually store things in the database and not worry about if the server restarts. Okay, so now we'll create some fields here, and we're going to give something called identifier. This will just be something, probably like a UUID. and it will represent something unique about that instance, because in theory you could have the same word like the written multiple times. We wouldn't want to use that as kind of like the primary key. And then we're going to give it an X and a Y. So this is where it would be positioned on the fridge, the hypothetical fridge we're going to make. And the fun thing I want to throw in is allowing you to actually change the color. And we'll be just saving that as a hex string. So we'll just use a string for that. We also want to control what the text of it is. So that will be a string. And then let's just also store a created at. So when this magnet was made. We'll just open up our terminal here. Okay, so in order to generate this file, first of all, we need to get our Docker running again. And if we go back to the docs, we should see here. So we want to run Docker compose up. So I'm just going to run that, I think from the server directory, if I'm not mistaken. Great. So now if we actually load Docker, now you do have to have Docker installed for this, which again is something you can easily Google. Also covered in my first series, but you'll see we have this running now, and it has the Postgres and it has the Redis right here. Okay, so it's still running, everything's good. I just kind of close the control panel for it, but up here you'll see I still have Docker running. So we have Docker, we are good. Now what we can do is actually generate that code. So to do that, it's just serverpod generate, and we're just going to run that like that. All right, so this should have done some things for us. If we go in the generated folder, we'll actually see this tables file here. And so this created us the SQL we need to actually generate this. So let's get our database stuff set up. So I'm using this plugin built into VS Code. You can do this with really any PSQL tool. And we're actually going to create a new connection. And we're using Postgres. Again, this is covered much more in detail on my previous series. And connection name, we'll just call this Flutter Fridge. This is just an internal name for us. Connection group, we can leave blank. Yep, server and port. Now here we'll need to go to our config files to find out what these are. So inside server config, and we go to development in this case. And we want to look for the database. So it is localhost, but it's port 8090. And the database name is Flutter Fridge. And the username is just Postgres. And for password, we're going to want to click this and use save as plain text in settings. Plain text sounds scary if you're like password in plain text, but this is just my local version, so I'm not really worried. Now to get this password, all we have to do is go to our passwords.yaml, and we look for database again underneath development, and we'll copy this, and we'll paste it in here. Now we definitely want to try the test connection button just to make sure we didn't ruin anything. And it looks like, yeah, we did something wrong here. So let's just double check everything. Database, Postgres, save as plain text. It is connection name, localhost 8090. Save as plain text in settings. Okay, everything seems right here. Let me just save it. All right, everything's good now. I was able to test the connection. It was simply because when I was R&Ding this project earlier, it's the same project name, and I already had a Docker file for it. So you won't run into that problem. But yeah, basically just fill out all that and get the password and click test connection, and we got successfully connected. So that's good. Now we can run that SQL. So I'm going to open this, and I'm just going to copy it. And we're going to go to our SQL tools, and we're going to go here and go connect, and we'll just paste this in, and we're going to run it on the active connection. And there we have it. So we are good, and we can double check this by opening up here, going to schemas, public, tables. We should see a magnet table now, and we can kind of see all the values, the fields that it supports. And I will just close this, and in fact, close everything. Okay, so we now have our lovely magnet object. All right, so the next thing we're going to do is just sort of set up a very basic socket connection. So we're going to go to endpoints, and we're going to make something called fridge endpoint. And in here, let's go to the example endpoint because we're going to want to import whatever this uses. And in fact, I'm going to copy everything, and we'll just get rid of the comments here. Okay, so what we want to do now, this is where we're getting a little something new from previous video is we're going to do something called stream opened. We're overriding that function there, which gives us back a streaming session. And we're not going to do what it would normally do. Instead, let's just print a message. Hello, world. And we just need to make this async so that it conforms to the future. And that's good enough for now. Okay, so let's go to the Flutter side now and open up Flutter. And let's go to our lib main.dart. Okay, so first things, a little bit of housekeeping I want to do. What we want to make sure we have in our main is that our widgets have been initialized before anything happens. So we're just going to put that code in there, like pretty much any other Flutter app you might have made. And let's do some stuff with our theme data here. So we can use the blue swatch, that's fine. But let's use material 3. We'll make it look a little bit prettier than the standard material 2. And let's set our color scheme. And we can just do this simply. We're going color scheme.from seed. And we need to have a seed color, which we will use the blue-gray sort of color here. And let's make the brightness brightness.light. And the reason I want to do this as light theme is because it is, we're mimicking the idea of like a fridge. And generally a fridge is really light in color. So we won't be doing this in dark mode. We can also rename, actually, we don't need this. Let's get rid of all this stuff here, just the default sort of Serverpod app that comes with it. And we're actually going to make a new file to handle where our home page is. So inside the lib folder, I'm going to make a new folder called source. And I think inside there, we are going to just make something, let's just call it fridge screen, fridge screen.dart. Oh, right. So here we'll just start by making this a stateless widget called fridge screen. And we're going to return, it won't be a const, but we're going to return a scaffold here. And in here, we'll just do sort of like a body of maybe center child text hello, something like that. I guess for now this can be a const. It won't be forever, but just get rid of that error message. Okay, now what we also want to do is I'm going to now convert this to a stateful widget. But very first, let's go to our main.dart and actually import this in. And it can be a const. Okay, and while we're doing some stuff, let's just set this to the simulator. And we'll just go to our main.dart and click the run button here. And we'll let that start up right for us. Okay, so back to our fridge screen. We're going to convert this to a stateful widget. So we can just go convert to stateful widget. That way we can have some init state sort of thing. So let's just go init state. And let's get rid of that comment there. And what we want to do is make a connection handler. So first of all, let's make that variable here. It'll be a late final variable. And it's of type streaming controller handler. And we'll just call it connection handler. And then down here, when we init state, we're going to actually initialize it right here. And it's of this type, and then we have to pass in a client and a listener. The listener takes one parameter of basically the connection state, so we'll just call it that, and maybe we'll just print that out in here, like the connection state. And then we're just going to do a set state in here, at least for now, just to update anything in the UI when something changes. Now this variable right here is our client that is actually automatically in here, part of our project. And we're not going to get, in the previous one, we got a little bit fancy and kind of made singletons and we're using Serverpod and stuff. But I don't really want to get into that here. I really want to focus on the socket stuff. So we are just going to import this. So I can just go like this from main.dart. All right. So now let's load this and we have our lovely hello. I'm just going to rebuild it, and let's actually just make this a little bit smaller so we can see this at the same time. Okay, and we don't have our server running, I realized, which is definitely going to be a problem. So let's run our server. And to run the server inside the server directory, we simply just go dart bin main.dart. Okay, it looks like maybe there's some errors. Let's see, internal, okay, failed to connect to database in feature call manager. Interesting. Oh, okay, so I guess we need to also run, usually that, oh, you know what, it's because when I was debugging, I killed the Docker a couple times to try and fix this while I was paused. But we can just fix that by, if we go into the server, let's close this, and I believe it is in generated table Serverpod. So we'll also just need to run this SQL. This normally gets run when you start the project, but I did some funny things in the background to fix my problem. So let's go to our SQL again, and we will go, I'm just going to disconnect and reconnect. And we will just run this on the active connection. Looks like it worked. And now let's restart our server again. Okay, here. So we have everything running all nicely. Let's relaunch our Flutter app. And in our main.dart, let's just see, or sorry, in our fridge screen.dart, we have our init state. See our debug console. Okay. I realized we set up our connection handler, but we didn't actually connect to it. So that's simply just connection handler.connect. All right, now let's just rebuild. So we are getting this back. Let's just see what we can get off of this. Maybe status. So if we rebuild, we're seeing, okay, we're connecting and we're getting back status connecting and status not connected. So that's really good. Now in our server, we should be seeing, when the stream is opened, we should be seeing hello world here. But we're not. So what could be the problem there? Oh, we should probably get rid of, we don't really need that anymore. And actually, this is probably the problem. Let's call this fringe endpoint. And let's run our generation script again. Serverpod generate. And restart our server. And there we have it, hello world. So we just didn't run the generator again. Okay, so now when someone connects to this, we are getting this hello world, and everything is great. Okay, so we're going to start by allowing a user to essentially create a magnet. So another override we're going to have to do is the handle stream message endpoint, and we will make this async as well. And we'll get rid of all this right here. Now, the way I want to kind of set this up is we're going to create classes, not database-driven classes, but just objects that are for our different types of events. And one of them is going to be creating a new magnet. So in order to do that, we're going to go to our lib of the server, source, protocol, and we're going to make a new file, and we're just going to call it magnet create message. And message meaning it's a type of like server to client or client to server message. Okay, so in here we'll just call this class magnet create message. Now we're not going to add a table because we don't need this to be database driven. This is just an event. And the things we're going to want to capture are the X value that it's going to be placed at, the Y value it's going to be placed at, the actual text of it, so let's make that a string, and the color, and that will also be a string. And what I'm going to do now is actually run the generator script. So we're going to run the Serverpod generate right here, but we're going to add the watch flag so that anytime we're making changes, it is going to auto-generate our code and we won't forget to run that. Now we will have to restart our server still in between changes because it's going to be using whatever the code base was in memory at that time. But there we go. Okay, so we have our magnet create message. And now if we go back here, the cool thing is, so this is going to be any kind of message that comes in. So what we're going to want to actually do is check what type of message it is. So we can go if message is, and this is just a way to check types. So if it is magnet create message, and you'll see this auto imported in the this file right here that has the magnet create message. This is just the generated code based on that YAML file. So we can check this, and what we will do is we're going to want to create a magnet. So we're just going to call magnet equals magnet. And this also needs to be imported. And there's some fields we need. So we need an identifier. Now, we could just trust our client to send up a random identifier, but that's not really, the safest way to do things. So we are going to just generate a random string. So we're going to create something called identifier, and it's going to be equal to a function called a function that we're going to make. And this is also in the last project, but I'm going to in source, I'm going to make a new folder here called utils. And inside here, we'll make a new file called strings.dart. This is exactly something we did, a generate random string. Very simple function that just will create a random string for us. So now we can do generate random string, and maybe it's 16 characters. You could also use a UID for this or whatever you want. So we're just generating one right there. Okay, what are the other things we need? So the X of the magnet will be the message.x. And because we're wrapping this in, and this isn't a Serverpod thing specifically, this is with anything with like abstract classes and inheritance. Because we're already in this VS Code knows at this point, it just thinks it's a serializable message. But inside here, it actually knows, it knows in its context specifically that it is of type magnet create message. So we can actually do message.x. Message.y. The color will be new message.color, and the text will be message.text. And now we're just missing one other parameter we need, which is the created at. And we're just going to generate that on the fly, datetime.now, because we're creating it now. Okay, so now we have a new magnet. Now that's good. And what we're going to want to do is also save this to our database. So we can just simply do that by going await magnet dot insert, and all this database stuff is covered in my last series, so don't be too confused. Unless you've watched that, then watch it again maybe. So that will now insert it into the database, which is great. So we'll start with that. And let's now, on the Flutter side, we'll need a way to obviously create this. So let's do that now. And I think the best way is a floating action button. So within our scaffold, let's just make a floating action button. And it'll be of type floating action button. And on pressed, we will come back to in a minute. But we obviously need a child, and we'll just do it as a icon. Icons dot add on pressed async. And this is throwing this error simply because this is no longer a const, because we have a dynamic function here. Okay, now this is where we can kind of see what's cool about Serverpod, where the code that we've generated works both on the server and the client. So we can actually create one of these magnet create messages, and we'll just call it message. So that got imported, no problem, equals, and we can just construct this right here. So let's just make one for us right now. And let's just do like an X of 100, a Y of 100, text of hello, and a color. And we will be using hexadecimal colors. So I'm just going to do FF0000. So that'll be red right there. And so we create the message, but then we also have to send the message. So now we use our client that we have, and we can go into .fridge, which I realize we have a typo here. Fridge should have a D. So that probably happened because, yeah, right here. So let's save this here, and that should regenerate our code. And if we go back here now, we should actually see. See, that was so painless, right? And what we want to do in the client, instead of doing a RESTful API call or anything, we're just going to send a stream message up to it. And we're just going to call it, we're just going to pass the message in. So I'll save this. And we need to remember to restart our server. And before I restart it, I'm just going to also print out some things here. Let's do like message.text and maybe message.color, just so we can kind of see it happening, because there's not going to be any visual things happening yet. Okay, so in theory, if I click this plus button, something should happen. Let's see. So you can see when we click this, we get that hello being printed and the color. And I'm not seeing any errors, so I'm assuming this is being saved to the database. So we can double check that by looking here and actually opening this up and going into here, tables, magnet. If we double click, nope, not double click, but click this little inspector here, we can see our two things. So they were randomly generated strings. They both have they're basically identical except for the time and the identifier, the stuff we set on the server. And this is the auto incrementing ID that automatically is used with Serverpod and with most Postgres databases in general. So that's great. We're saving data through we're not communicating through a RESTful API. We are communicating through a socket. But what we did right now, there's no really reason to use sockets yet. We haven't done anything that socket driven. So let's figure out the next part of this. But before we do that, let's build sort of the front end here of how we want this to work. So we're gonna go back to our fridge screen, and in our body, instead of just saying hello, we're gonna do something a little bit more interesting. So I'm going to create a stack. So stack is kind of like a column or a row, but everything's on top of each other on that axis. And for our children, we are going to take all of our magnets. So we don't actually need this. We're going to go magnets, which I realize we don't actually have yet. Let's figure out how to get those magnets in our view here. So first of all, this is a stateful widget, so it's pretty easy for us to deal with this. Let's make a final list called magnets, and it'll be of type magnet. And we're going to equal it like this. Now, although this data will be changing, we can still make it final because we're not ever going to be, actually, we probably shouldn't. It'll be easier for us. We'll make it something that is not a final. It is something we can update. Okay, so the next thing we need is, so we have the event handler for, or we need to make basically an event handler for when new magnets show up or they're moved or anything like that. So what we're going to do is when we init state, after we've initialized all this stuff, we're going to just call a function called listen for updates, which doesn't exist yet, but let's make it right now. And we'll make this futurable, listen for updates, async. And in here, we're just going to await a list right here of messages. So var message in, and we can go client.fridge.stream. So this is like the stream of all the messages that could come in. And we can essentially check in here for, if message dot message is, and this is where we do the type of message, we can do things differently. So let's set up a new kind of a new type of listener here. And to do that, just like we did, we are going to go into our lib protocol, and we're going to call this one magnet state message. And this will basically be a message that at any point we'll just tell, the client, this is the state of all the magnets in the database. This should be a YAML file, of course. And this is a pretty simple one. We'll just call it class magnet state message. And its field, it's only going to have one field, and it's just going to be called magnets, and it's going to be a list of magnet. Hey, it's so smart. And we'll get that generator happening. Yep, we're good. Sometimes you'll see like errors in here because when you make that new file, it actually tries to, it's like, oh, a new file, I'm going to try and execute it when you're running the watcher, but it's just because the file is empty and it can't understand it for obvious reasons. So now we'll actually have, without too much effort, we can now check if it's magnet state message, which is great. And now what we can do is essentially just set state, and we will do magnets. So our variable magnets is going to be equal to message dot magnets because it knows that this magnet state message will have that. And we'll want to make sure that that gets broadcasted when a new connection happens, so that the new user coming on can get the fridge as it is. So what we can do in here is we have the stream opened, which doesn't do anything yet, but we can essentially send a stream message, and we'll pass in the session first, and we're going to use that same class magnet state message, and we're going to want to pass in magnets. Now, where do we get that value from? Well, we can just do this and go final magnets equals await magnet dot find session, and this is just a way to get find allows you to get this should be multiple, right? Yeah, this will get you a list of things, and you can, of course, if for some reason we want it to be specific ones, we can do where clauses, but we want all of them at this point in time. So we just get them, and then we essentially send that stream message right over. And because this is listening for that stream message, we will get those magnets. Okay, so now here, back to where we were before I got a little ahead of myself. We can go magnets.map. And here we will, we'll just call this maybe magnet, makes sense. So this will basically loop through all the magnets. And let's just call this M because we might work with it a bunch. It'll be easier. And in here, we're going to want to return something. So let's just, for instance, now just return text. And let's just do M. Oops, I realize there is a problem here. Sorry. Okay, and there's some missing. What's this saying? Magnets. Oh, interesting. List of magnet. Is this pointing to the right thing? Yeah, magnet. Children. We just have to remember to convert it back to a list. Um, and this needs to say m.text. And we're missing maybe just there we go. Okay, let's clean that up a bit. And let's just restart our server. Remember to do that. And we're going to rerun this, the green arrow. And you'll actually see up here, we have this hello. It's a little hard to see because it's right in the top right corner. If I put this in the center though, you'll see that. And there's actually two of them. They're just they're just right on top of each other. So what do we actually want to do here? Because we want to make use of the X and Y. So we can actually use a positioned object here. And what we want to do is give it its, we'll do the child after, but let's just do the top. And that's going to be the m.y, which we need to convert to a double, just because position is doubles, even though we're only storing those integers. And the left will be m.x.toDouble. And the child, in this case, let's just do text. And this will be m.text. So likely this will look basically the same, except it's going to be somewhere around here, is my guess. Yeah, right about there. So we have two of them on top of each other. Yay. So that gets us our text where we would want it. And that's looking all right. So let's, just so we can actually work with this a little better, we were just kind of constructing this this guy right here with, pragmatically, it's always going to be the same. We should probably be asking for some user input here. So what do we need to know? We need to know an X and a Y and the text and stuff. So I'm going to create a new file on our Flutter side. Let's go into source and let's just make a new file. And we'll call it create magnet modal.dart. Okay, so let's start by making a stateless widget. Create magnet modal. And let's go back to our fridge endpoint. And basically here, oh, that's the wrong, sorry, not fridge endpoint. I want to go to our fridge screen. And we're going to await show modal bottom sheet. And the builder itself, we are going to context, and we're going to return create magnet modal, which we need to import and go like this. And let's just return out of this for now so that we don't actually just make a whole bunch of magnets by accident. And we need to save this file. So now if I click this, we should see this lovely modal coming up. So in here, we're going to want basically something to capture this different variables we're going to make. I'm going to write that up really quick right now when I pause. This is just like a basic Flutter thing. I'll walk you through it, but I don't want to waste time in this video just like showing you how to do basic Flutter stuff that you probably already know. All right, welcome back. I was, from your point of view, gone for 0 seconds, but it was a little bit longer than that, I will assure you. So this is what I've come up with. Just a nice little modal that lets you type in a message and choose a color. So what we've kind of set is a list of some colors here that I thought are readable on white. Very easy to change, of course. And we've made this a stateful widget just so we can change some things about it. So this is just pretty basic. We have a column here which has add magnet text. Then we have this text field, which uses a text editing controller so that we can get the value from it. And we then have the color text, and we're just have a row that we loop through those and put these guys in. If we had more colors, this might have to become a wrap, but it seems to work fine. And yeah, we just, when you click this, it's just changing the state. And I'm even changing the color of this button, some really fun stuff like that. And basically what happens when you click the add button, which is probably the most important part, there we have it. So what we actually do is when that's pushed, we actually pop the navigator, and pop allows you to place in not just popping null, which is kind of the default if you just close it like that, but we can actually send anything back when we pop. As long as we're awaiting this, as long as right here we're awaiting, this will come back with a value. Now the value can be null, so we have to make sure we care about that. So we are popping, and basically we're putting the X and Y as, I kind of just set some default places, X and Y, just so it doesn't show up, off the screen, basically, like 0, 0, wouldn't really be viewable. And then we pass back the text based on whatever's in that controller, and we pass back the selected color. So you'll be able to look at the code to see, this in a little more in detail, but there's nothing really like Serverpod-y about this. We just needed to make something, so that's why I wasn't present for that part. So now we have this, and we're going to make something called new magnet equals this. And I'm actually casting this as a, the return on this is going to be a magnet create message, because that's what's coming back when we pop. But it is nullable. So you'll see here that this now gets the magnet create message like that. So that way we can actually just use the same data, instead of just returning JSON or making a new data model just for Flutter side, we can actually use the same data model. Okay, so now here we get rid of this, and we'd want to make sure if new magnet does not equal null, and we probably also want to make sure that, because we didn't really do any validation on that side, so let's also make sure that new magnet dot message or dot text dot is not empty. Then we'd want to actually send this. And instead of sending message now, we will just send a new magnet. Okay, so no server side changes there, so we don't actually have to restart our server, but let's just do this. Now, this won't work exactly like you might be expecting yet, and you'll see why in a bit. I'll just put my name here and choose blue and click add. And as far as we know, it worked. The problem is we don't really have any events right now, like, oh, a new magnet's been made. But watch, if I restart and actually rebuild the app, we actually see my name is right there. Very cool. So let's get this to actually auto import. So back in our server, which I think I have here, I'm just going to get rid of those prints that we don't really need anymore. We need a new type of message, I believe. So let's figure out that next. So I'm going to go into the server side and go into lib source protocol. And we're going to make one called new magnet message dot YAML. And we'll see this lovely error come up here. And we'll call this magnet. Actually, I'm going to call this magnet append message. So we'll actually rename this file. But first, let's just do it. And this is just going to have one single magnet. So we'll save that file. And I'm just going to rename this to be similar to the class. So magnet append message. So this would be a message that is sent to all people connected when a new magnet shows up. Okay, so let's go back to our fridge endpoint. And right here we have the inserting of it, which that is great. But what we can do now, and this is where we'll get our first one of our, I guess, first server talking to the client, other than the one that happened to the connection. So after we insert to the database, and in fact, we could even do it before, but we'll just do it after. Session.messages, this is another thing we have access to on the server, and we can post a message. And here we're going to type in a channel name, and we're actually just going to call it magnet channel as the variable, and we're going to make this a constant. Magnet channel equals, and I'm just going to call this magnet channel. This is so you could have multiple, channels or rooms or, various things like that. We're just having one. And we're going to want to put in a message here. And here's where we're going to use the magnet append message. And we're going to want to pass in the magnet as this magnet. And I'm just going to set global to false. I don't know if this is needed, actually, but that's for if we are doing, if you have like multiple servers and stuff, it can share them to all of those. So let's restart our server. Then back on the client side, we need to add another thing here. So we have this if message is this. We can also do if message dot is, message is, and this we do magnet append message. We might do things a little bit differently here. So in the case that we get this append message, we're just going to set state by going magnets equal whatever the current state of magnets are, and we'll add in the message dot magnet. So that'll give us the new one. So let's try doing this one again. Test2 purple, and I realized I might have not restarted this. Let's just see. Did I restart the server since? I feel like I did. I'm just going to write a really long message. Okay, there's something is missing here. All right, there's one important thing we forgot. So when we open a stream, we also want to go session.messages.addListener and specifically choose that magnet channel. And we'll just call this update. And what we're going to want to do is actually send stream message session and send the update out. So this means whenever we post a message, the client, there's basically a connection here that's going to send that message. And I believe that's why this was not working. Let's restart the server. And this might be a little difficult to see because we're getting all these messages in this one spot, but let's just, I'll try to write something really, really long. And there we go. It just got added in right there. Okay, awesome. So we now have this little bit of socket stuff happening. And what's cool is that if I was to also run this in web, let's do that real quick, or a different simulator or whatever. So let's just go cd ... cd flutter and flutter fridge flutter. And we want to do flutter run -d chrome, I believe. And here we got this guy starting up here. And hopefully, if all goes well, we see these things here. And if I was to, on this side, create something else, you see it popped in here and it popped in here because both clients are connected. So we'll close that for now, but we may come back to you. Okay, so now what we need to do, a big part of, this isn't just a thing that you generate magnets and that could, we'd just be making like a Twitter where everything shows up on the Z-axis. We need a way to allow these things to be drag and droppable. I think first, I'm going to wipe my database just so we don't have all this, annoying stuff happening here. So a few different ways we could do it. There might be just a way through here, actually. Let's just see. Can you delete? I don't think this allows you to delete. So what we're going to do is we are going to connect back to our server here, and I think it's drop table magnet. So let's try running that, and that's good. And let's just restart our server. Now we'll probably get an error because we need to, oh yeah, there's one more important thing we need to do. So I dropped the table, which is great. We also need to then rerun the table generation code. So that's just in generated, Flutter fridge server, generated folder and get tables. And we're going to want to go back to our SQL and run this. Okay, great. So let's do that. Let's start our server back up. So now at least we'll have, this empty nest. And we'll restart. And you see there's nothing there. So that's good. So let's add one. And let's make it purple. Okay, cool. So let's start by styling up how we really want these magnets to look. Okay, so let's see. Where are we doing this? So right now we have this positioned object here, which is great, but we kind of want to make this look a little bit prettier. So I'm going to take this text here, and I'm just going to go and extract widget, and we'll call this magnet container. We don't want to call it magnet because that'll conflict with the model. Magnet container, and here we're going to want to pass in a magnet, and we'll just call it magnet. And we want to make that the first parameter. I usually will just use positional arguments when it's a component that represents, a particular instance of something. It just makes a little more sense to me. Rather than writing like magnet, it's kind of obvious that's going to be for a magnet. So we can just pass an M, and let's just write this out a little bit better. So this will be, the UI that represents the actual, magnet itself. So let's see, let's just get rid of all this. And what I want to return is a container. And we'll give it a color, even though you won't be able to see this yet, but if we change our background, we will. So we'll make it white. Let's give it a border radius. Oops, I forgot. This should all be within decoration, box decoration. So we got our color. Let's give it a border radius dot circular, maybe like 3.0. And let's give it a box shadow as well. So here it's a list of things, and we'll just do box shadow. And I'm thinking like an offset of kind of like 3, so that'll put it, shift it over 3 by 3. I don't really want any spread radius or blur radius, so we'll do 0. And for color, colors.black12. So this whole thing, I think, now can be a const. Okay, so now we have the container that, the stuff will be written on. And within this, we're going to take, oops, not here, but here, we're going to do the text. And this will be the magnet.text. And let's give it some style. And text style, font size, 16. Font weight, I'm going to make it bold, but not like super bold. And color, this is where we can do something fun. And I didn't show this, but I do have these, I made these helper functions when I was sort of making that modal, just stuff to convert hex strings, a hex to color, and whatnot. And here we would pass in magnet.color, which is the string version of it, but we want it to come back as a actual color itself. So now see we have that. Now we just want a little bit of padding on this. So let's do, I'm going to do symmetric padding so that we can have vertical 4 and horizontal 8. So a little more on the left and right. Now we got that little thing there. Now it's a little bit, a little bit hard to tell where this box is because we already kind of have a light colored thing. I can notice it. You probably maybe can't on the stream, but we're going to eventually put a different background here and it'll be more obvious. Okay, I'm just going to add a couple guys to make this look prettier. Okay, cool. So now we have our magnet container. Now, what we want to do is actually make this draggable. So what we can do is we're going to wrap the magnet container with a widget called draggable. This is just a built-in Flutter widget. And we're going to do feedback. So the feedback is kind of like, what does the user see in terms of what it's dragging? And we're actually going to let it see a magnet container. And we'll pass in the magnet. This is one good reason why we made this a reusable component. What we're going to do is wrap this in opacity and give it an opacity of, say, 0.5. And we'll just put in a comma there, maybe a comma here too. And now you'll see if we drag it, although, yeah, so you can kind of see this little guy here. Now see how there's like this yellow line happening? That's because technically the draggable, this thing in here isn't inside a material element by the way like draggable works. It's kind of, I think, hoisted outside of like the scaffold on like its own layer. So to fix that, we can actually just wrap this entire widget in a material component, and we won't have that anymore. Okay, so we have that. Now, what we're going to want to do is actually, do something when this is dragged. So we have the child of draggable. Okay, draggable. And what do we have right now? We have feedback. We have child. And what we can also do is child when dragging. So you'll see when I was doing this, you still see the original one, which is fine. But I kind of want to just have a just like an empty container, basically, so that you don't see the one when it's being dragged. So see how that is? That's kind of cool. It goes away. And what we want to do now is have a on drag start. And I'm not going to do anything here yet. We might come back and do something. But the most important is on the drag end. And here's where we get some things. So this takes one variable of the drag's details. So we will work with that. And this is where we're going to, when the drag ends, basically talk to the server and say, hey, this thing moved. Now, there's a little bit of complexity to doing this because we want to know its exact like X and Y position based on the container it's in. So to do this, we can make a render box. And it's technically nullable, so we'll just go render box this. And what we actually want is we're going to make a global key so that we can work with this. So I'm just going to put this right in here, key, and the key itself will be on the stack because that's where all of our like positioned information is being placed. So we can just go key, key. So this will allow us now to go, we can get the key dot current context. Now we could have called that like, I don't know, like container key or something, but this is fine. So we get the current context, and then we want to find a render object. And we'll cast this as a render box. So this is essentially going to give us the render box of that whole stack, which actually I believe is this entire screen, just the way they have this built. But this would allow us, if we only wanted our fridge to take up a part of the screen, it's going to be representative of just that. Okay, so we have that. And what we want to do is find the offset. So we're just going to create an offset object, and we're going to call it position. And we're going to take that box, and we're going to go dot local to global offset dot 0. So this is actually getting us the offset, the position of where that box is in the coordinates of the entire app space. In theory, because I think the way we have this, it'll be the same, but I want to build this in a way that, if we change things, it wouldn't just break. Okay, so now all we need to do is go, we want to first make sure that position is not null. And it could be in various cases, so we're just going to make sure it's not. And here we're going to get our new X position, and basically we just take the drag details, dot offset dot dx, And we need to subtract it from position.dx. And we do the same for y. And now we have our x and y. Okay, so now what we're going to do is actually send the message to the server. So we need a new thing for this, a new data type. So let's call this, so we already have magnet create. Let's make it, we have magnet append. Let's make magnet update message dot YAML. And in this case, class magnet update message. It's so smart. And the fields, we're going to take the identifier, which would be a string. So this is the identifier of that magnet, that like randomly generated string. And we are, the only things we're allowing changing is like the x and the y. So we'll just do that. So now we have that lovely new thing there. And we're going to now make a new message, final message equals magnet update message. And we're going to pass the identifier, and that's going to come from the magnet dot identifier, not ID, but identifier. And the x is going to be that x there, but we need to round it because it is a double right now in terms of this, and we want to turn it back to an int, and round is probably the easiest way to do that. So now we have a new message, and then all we need to do is send that message. Up to the server, and that's pretty good. Now on the client, we also need to make sure we're listening for that message. So let's do that too. If message is magnet update message, okay, so now what we need to do is find out where in that stack of things that one is. So first of all, we'll just make a variable called index, and it's going to be equal to magnets.indexWhere. And we'll just, instead of element, we'll just make that m. And we want to go m.identifier is equal to message.identifier. Now this will return always an integer. And the way the index of works if it doesn't find something is it actually returns -1. So if it doesn't find anything, we don't want to do anything, but we want to just make sure if the index is greater than -1, then we will, go. Okay, so we're going to just make a let's make this a var for now. So we're going to call this updated magnet, and it's going to be equal to magnets at that index. And we can go updated magnet.x is equal to message.x. Updated magnet.y is equal to message.y. So now we have our updated one, and then what we can do is make a variable called updated magnets, and we'll just take the current state of magnets, and we want to remove at that index, and then insert at that same index. This is just a quick way to replace that updated magnet. Then at the very end, we just go set state, and we just say magnets is equal to updated magnets. And there we go. Okay, so I'm going to restart our server because we made a server-side change. And she's not working yet. But we're getting close. And I think it's just because we aren't actually doing anything with this type of message. I think we just forgot one pretty important thing. Yes. So we have right now the handle stream message. If message is magnet create, we also have to kind of have the same logic here. So if message is magnet update message. So what we need to do now is actually find that magnet in the database. So we'll go await magnet.find single row. And we pass in the session first, and we do a where clause. So here we go m, and we want to go where m.identifier equals, and here we pass in message.identifier. And we just want to go, if magnet does not equal null, because maybe something went wrong and it doesn't exist anymore. So assuming it doesn't go null, we just take the magnet and we go .x equals message.x, and magnet.y is equal to message.y. And then we want to post that change to everyone listening. Session.messages.post message magnet channel, and we're going to pass in that magnet update message. So it's kind of cool how we're listening for a type of message and then using that same data type to also then do something to our database and then broadcast out the change to everyone. So we want to just pass in the magnet identifier, and then this will be the magnet.x and magnet.y because we've already changed those. We could also, in theory, be using the message, .x and message.y, but it doesn't really matter. And we want to make sure we also save this change to the database. Session and magnet. The update function is really handy because it knows it'll automatically update it instead of making a new one, because this one has an ID already, and Serverpod just does this magic. So yeah, basically this will, when it gets this message, it will try and find it, and if it finds it, it's going to update the X and Y's based on what was in that message, and then repost that message to everyone else. So let's restart our server. And there you have it. So now it's actually staying put where it should be, and even if I restart, we'll see that happen. Now for the real beauty, of course, we're going to just open up another thing. Let's just run this in Chrome again. I'll just pause for a minute while that starts up. Okay, so we have Chrome started up now, and if I move this guy around, you'll see it actually moves on both sides. So that's pretty fun, but let's make this a little more fun. So back in our client, what we can actually do is we have our positioned object. There's also something called animated position, and we can just replace position with that, and all we have to do is set a duration of milliseconds, maybe like 500 or something. And this will look a little bit funny on this side, but you'll see how it kind of like moves. Now, what we can do is, because this is really meant for like, if I would say I'm on this one, it looks really cool from that guy's point of view because he just sees it, although I have to, I think, refresh. Oh, right, because I have to hit R here to reload to get the new code. We actually see like it kind of moves, and that's cool. But we don't really want to do that here because you'll see it like, it kind of should just go where you put it. You've already kind of done the animation in some sense. So we gotta like hack our way into, handling this. So what I'm going to do is in the up where we have all of our other variables, we're going to just make another variable called animation duration milliseconds. And let's just use that variable for this. And what we want to do in our dragging, this is kind of why I created this on drag started. What we'll do is when we start the drag, we're actually going to set the set state of the animation duration equal to 0. Then, whenever we finish dragging, we'll just do a future dot delayed duration milliseconds of 300 dot then, and we'll just set state again and set it back to that 300. And this can be a const, and this can just be an underscore because we don't actually use that value for anything. And let's just refresh on there too. So now from here, it doesn't actually animate because we're essentially, when we start dragging, we set that animation to 0, and we don't set it back to 300 until 300 milliseconds later. But if we look at the client side, the other one, you'll see it animates. So just a nice fun little touch there. And if I move this one, it's being a little bit finicky on the web version, but that's fine. All right, so let's add a new one called, let's call this Chrome. and we'll actually make it green, for instance. And look, it just showed up instantly. We can move it there, move it here. There's obviously like, doing this as a cross-platform app, you run into funny things where like, you could build this and only people on large screens, they could be having their own little party over here that the iOS doesn't know about, unless we added in some kind of like scroll ability, kind of like a Google Map pan or something. They would never know it's there. Perhaps if they turn their device, oh, look, you can start to see it. That's pretty cool. But that's not something we're going to worry about in this. That's something you can solve on your own if you care about it. Cool. Now, yeah, I think final touch here, and probably the most important thing is we need this to look a little more like a fridge. So let's go to our main.dart to start off with. And something I usually do first, but did not do this time, is probably the most important thing. Let's turn off that stupid debug menu there. And then I have this really cool file right here that we're going to throw into the project. So I'm just going to grab that, and in Flutter right here in assets, do we have the assets folder? Guess we don't. Okay, let's make that folder. New folder, assets. And we'll just reveal this in Finder, go into it, and paste this in. Then in our pubspec.yaml, there's so many YAML files, so pubspec.yaml for Flutter. We just want to, I'm just going to sort of like uncomment this. And I actually forget, it's been so long. We can just go within assets and just literally go assets slash. And here I believe we may need to do a full rebuild of our app, but let's get the code ready for this. So we're going to go to our screen, and basically we have our scaffold, which does the stack, but we're going to wrap this stack in a container. And we're going to give the container a width of double.infinity and a height of double.infinity. Then we're going to give it some decoration, box decoration, and it's going to have an image, and we can just use decoration image, asset, image. And here we would just do assets slash background.png. And for its fit, we will do box fit.cover. And this whole thing can basically be a const. Now we'll, oh, look, I thought we might have had to restart the app, but we did not. So now it is, a little bit better because we have this lovely thing. And if we restart Chrome, Chrome, I think, is where we might have to actually rebuild. Yeah, it's not liking it. So let's rebuild Chrome so we can get this lovely background. But now it looks like a fridge, so we can all, celebrate the lovely fridgeness here. So that wasn't too bad. More or less an hour for a Socklet application. Obviously, there's more stuff you could do here to make it your own, but this is cool. Let's just make sure this works on this side too. Although I realize we already did test that, so we're good. Now this isn't, we probably want a different background for web because this is kind of getting blown out and doesn't look great, but I don't really care about that right now. All right, that's it for this tutorial. The code is up on GitHub as it stands right now, and feel free to check it out and like and subscribe. See ya.